Welcome to Science Innovative Brain. Today's video lecture, we will discuss here how we can make a schematic diagram in Kicad. So here I have one power supply schematic diagram. This schematic diagram we will make in Kicad. So this circuit, if you want to learn about how this will work, then you can refer my previous video lecture. In that one I have explained all those things. So now we will go for the schematic making. So for that we will open the Kicad, and after opening the Kicad we go will in the file menu, and then we'll select new project. After that new project we have to save the file name, so we will give the file name lm2576 power supply power supply supply, and we'll save it on desktop or whatever place you want to save it, you can save it. So just click save. After the clicking on save button, then we will get two files here. It will show two files it is generated. One is called schematic capture and another is PCB file. So now in this video lecture we are discussing only about the schematic generation. So we'll click on the schematic file, double click we have to do. Then after that you will get here one window or one page. In this page we have to draw the circuit or schematic. Here if you see the title blocks is given, so in this title blocks we can define the values. Just double click on this one, and here issue date is coming, just clicks here. So whatever date is there here, same date will reflect it here. In the revision version you put the revision drawing, so I will put R01 because it is a prototype design, first design. Then put the title, so title is the power supply, so I will write power supply, POWER, power supply. Company name, you can whatever you want you can put it, or you can leave the blank also. So here I will put science to Science Innovative Brain. After that you just click on OK. So if you see here, it will reflect on your schematic diagram. Here the title, name and revision version and date, what date you have made the schematic. Then after that we will here draw the schematic with the help of the schematic which is we have opened here. So here to draw this schematic we require these components. So for that we have to add the symbols. So we will search in the Kicad. Here add a symbol, left side it is given here. Otherwise you can find same thing in place menu, add symbol. After that this window will open, and here you have to search it LM2576. Then you can see here so many types are available: 3.3 volt, 5 volt, 12 volt, 15 volt, adjustable. This HV means high voltage ka type is there. Then you can select whatever you want it. You want it SMD type. If you see here I have selected this first one, so this is SMD type package, so it is a SMD package. Now if you want to choose a through hole type, we will choose the through hole also. So but we will choose adjustable type. Here we will choose LM2576T adjustable type, so that, and it is a through hole package. You can see here through hole package, it is written here also. So now we will make OK, and this part will commit here. Okay, now we have to place the another components. What is that? That is a capacitor, and then a diode. So we'll select the capacitor. So again we'll click it here, capacitor, you type C. If it is electrolytic, you select electrolytic. So electrolytic, so we'll go it down, we'll see C polarized is there, this will select and keep it here. Then another components is diode, and another components, two components capacitor, so we'll select one more, and then diode is there, so we'll click and we'll put the diode. So here diode name is 1N5822. We'll check whether it is there or not there. 1N5822 is there. Yes. So we'll select this diode here. It's came. And then what we need a resistor, inductor, and potentiometer. So we'll select resistor, R, resistor is there, then potentiometer, and then inductor. So we will choose potentiometer. Potentiometer, it's having three terminal. Potentiometer. Then we have to choose the inductor. For the inductor, we'll place L. So inductor symbol will come. And then all components are chosen, but we require the input terminal and output terminal blocks. So we will choose some connectors. So we'll choose here connector. We will choose 1:2 pins. So male, female, whatever you want, you can choose it. So here we will choose these two male connectors. So this is input, and that is this side, it is output. Now we will make the connections. So connections, first we have to connect the capacitor. So here we'll take the wires, and from the wire first it will go to capacitor and pin number 1. So from the pin number 1 to 1 we will make connections, and then one capacitor we will connect at this point, and then pin number 2 is the ground. So here with respect to ground we will connect this point, and then we will connect pin number 3 and 5 to the ground. So pin number 3 and 5 to be ground. So this is the ground line, and this is pin number 5 also, ground line, ground line. And then pin number 2 we have to connect the diode with respect to ground. So this is there, just highlight and press R to rotate. So it is rotate, and then connect and use the again wire, add wire, and make the ground. This is the ground. Now next is inductor, we have to connect. Then this inductor we will take it, press R to rotate, and place align, and then take wire and connect it. Then after that one capacitor is there, we will connect the capacitor. We'll place the capacitor here and connect capacitor, another terminal is ground position. After that this is the final output, and we have to connect one potentiometer and resistor. One potentiometer, this is the part of this potentiometer only, and then one resistor, and make the connections. This is the final output connections. So we'll take the output connector which is giving the output. So we'll connect with pin number 1 to this point, and then potentiometer terminal to pin number 1, pin number 3 to here, and then we'll put the ground, and pin number 2 is also ground, and this pin number wiper connection will go to the pin number 4 of the IC. Same connection, wiper connection terminal is went to the this part, and then in the wiper also one part is connected to the this part, so that it will start the varying. Otherwise it can, that is also possible if you not connect also, but if you connect it will proper, it will vary. So this is the connection happen, and then anything is pending, we'll check, revise, all our connections done. Now we will define the values. So here this connector we will take output connector, output, and then the values we will put it here. So click on R, and what value is written, that is written 1.2k, so we'll write 1.2k. Potentiometer value also we will write it, so potentiometer 47k, so we'll write 47k, 47k, 47k. Then next value is capacitor is 220 microfarad, so this capacitor value will write 220 microfarad, 220, sorry, 200, 2200 microfarad. So mu f, if it is voltage rating is defined, you can write the voltage rating also, there is no issue. And then diode is not required because it is actual symbols. And then first capacitor 100 microfarad, so we'll click it here, 100 microfarad, and input is the connectors. So like that this circuit is now fully completed. Yes. Now what we'll do, we have to define the ground plane, ground. So here the add the power ground is there, that you select G and D, ground, and then connect to this pin. So this is connected. Now we have to annotate the schematic here. So because the capacitor numbers, all diodes number, this is not defined, so what we'll do, we'll go in tool, and in the tool here annotate schematic is given. So just click on this annotate, and same default you select it and make annotate. After annotate it will tell annotate completed, and close it. After that you will see here C1 written, U1 written, L1 is written, and the values all are written. Here we have defined the L value, so L inductor value is 150 micro Henry. 150 micro Henry. You can see here U1 or whatever you want, you can put it. Now this is the input connector. So we'll write it input, input, what the value is given, 8 volt to 40 volt. That is also we can define 8 to 40 VDC. In output also we can define output is 1.2 to 36 VDC. Then just click on save. Don't forget, otherwise if anything happen, your system will that value you have to again redraw it if file is not saved properly. So now this schematic is completed. So now to check, just go in inspect and place electrical rule check. This is very important. It will check whether any electrical fault is there or not there. So it will check it. So just click it and run the ERC. After running the ERC, you will see so many things are 4 error but 0 warning. 4 error are coming. So what error is there? It will show it. Ground, whatever the mark is there, at that place it will show the errors. So there is input power pin is driven by any output power pins. So here what we have to do it, we have to go to the symbols, we have to put the power flag. So search flag power flag symbol and take and put it here to power, and one is to ground. And now again you try to check it, inspect electrical rule and then perform. Now two errors only it is showing. Pin is not connected, J2 pin is not connected, and again J2 symbol pin is not connected. So here it is showing pin is not connected. Yes, we have made reverse, so that's why it is not showing not connected. So what we'll do, we'll select and then we'll rotate first this connector, or you make it to mirror horizontally and then connect it. Now I think it is connected. So again you check, inspect electrical rule check, then there is no warning, no errors. So it means that our circuitry is fully properly made. There is no errors in the circuit. So in this manner we can make the circuit. You save it, and if you want to make print plot, if you want PDF files, so you go to plot here and you can plot the pages whatever PD. If you want PDF, you can put PDF also. You can see that output directly, place it the on desktop. I will show, and in any desktop folder is there, so will same file folder will select power supply folder, this one only, and then we will place and will plot the all pages. So we'll click plot the all. This is done. Now if you go and check it here, that the file is here and this file is now generated. electrical schematic is made it here. You can see it. So in this manner, we can generate a electrical schematic in the Kicad software. I hope that you have understand how we can create this electrical schematic, electronics schematic in Kicad. In next video lecture, I will explain how we can make same thing the power supply PCBs. Okay, thank you. Bye bye.